Thank you. Good afternoon, ladies and gentlemen. It's a great pleasure to be here. I'm a corporate senior vice president and chief digital officer of Toshiba, but I am not here today as a representative of Q-Star. So we are very familiar for the Q2B event because Q2B event logo, similar Q-Star's logo. Right. Q-Star was established in 2021 by a good cross-section of the Japanese industry, including Toshiba, to use quantum technology to promote new industries and businesses, to shape Japan's international competitiveness in the fast approaching quantum era. Membership is open to both large and small companies, including venture companies and startups, and to academia. In the 2 years from the establishment of Q-Star, we have made good progress. We started with 11 members and now have 73 with a good balance of vendors and users. The executive committee now has 8 working groups, and we will soon increase the number of subcommittees that create the use cases to 6, which I will explain later. In the first year of Q-Star establishment, after repeated discussions among representatives of academia, the government, and the industry, Vision of Quantum Future Society was published last April. Q-Star participated in the review working group, which complements Japan's quantum technology and innovation strategy. Last year, Q-Star activities focused on creating use cases. We identified more than 50 use cases and selected 16 as a basis for the roadmap for industrialization. Another accomplishment last year was that we also contributed in making strategy of quantum future industry development, just published in this April by the Cabinet Office, which targets to achieve the goals set the vision of quantum future society. And this year, Q-Star is shifting focus to demonstrate the application of our use cases to actual industrialization. The scope of Q-Star is very wide, as it aims to create industries through the comprehensive alignment of quantum and related technologies. The majority of members now are user companies, covering the scope of quantum technology and a wide range of fields necessary for industry creation. The Q-Star Executive Committee has 8 working groups covering themes you can see here. The work and recommendation of the upper 6 were incorporated into government visions and policies. Legal compliance and human resources developments are new, established last year, and were set up to meet demand as Q-Star activities evolve. For many members, the main reasons for joining Q-Star is participation in the subcommittees and working with our diverse membership to create use cases. We now support subcommittees working in the 5 areas you can see here. The quantum materials, devices, and the sensing subcommittee is now preparing to start activities. From here, please let me explain more about Q-Star activities. We have 5 core policy goals aimed to build a society fair use of quantum technology is for everyone. Promote globalization of quantum technology. Support participation of quantum vendors and users in the venture business markets. Expand the scope of quantum industry. Promote quantum industry by training human resources and widely disseminating information. Promote industrialization through industry, governments, academia collaboration. We now see three major themes. We need to work on the advanced social implementation of quantum technology. One is early linkage and demonstration of quantum technology with classical computers. Secondly, we need to increase the experience of actual machine user-driven proposed use cases. Lastly, we lack standards, and we need to establish benchmarks. As you are aware, quantum computers are roughly classified into two types, Ising types and gate type. Ising type, also called annealing type, dedicated to combinational optimization problems. In relation to Ising type quantum computers, there is growing practical use of algorithm described as quantum-inspired. These emerged from studies quantum computers and can be executed by conventional digital computers. They are expanded to accelerate the application of quantum technology into many areas. As you see from the names here, members of Q-STAR are developers in this field. And we will use this to advance the progress of quantum industrialization. To make use of our strengths in Ising type, we need to develop environments that bridge quantum and classical technologies. And to advance cumulate verification in the hybrid environments. We will first do this as a vendor environment, and then consider use of quantum and AI cloud. Meanwhile, Q-STAR and NEDO is a national laboratory development organization, have developed a quantum cloud testbed environment for annealing machines, which allows to verify diverse use cases. To summarize our expectation for the creation of an integrated environment, we believe that the key to industrialization of quantum computers is whether or not they are superior to full classical systems in terms of the end-to-end solutions. We believe that it is important to accumulate experience in order to make quantum computers work. It is also important to bring together the wisdom of industry, government, and academia, establish the benchmarking method, and lead to the world disclosing these methods of public for international standardization. Furthermore, it is important to expand understanding and participation in quantum technology through classical quantum hybrid environment in collaboration with ABCI and supercomputers, and through programs to introduce quantum technology to classical human resources. So to give you an example of what where we are heading, the Japanese government recently started to build a metal-scale testbed for quantum secure cloud based on the next generation computing and cryptography infrastructures. This involves a hybrid application of quantum and classic computers, as well as QKD and PQC. A wide range of the user from public to private organizations, such as financial enterprises, will be able to develop and verify practical applications over the testbed. This is an important step for the development of quantum technologies and solutions in real-world use cases. I'm very pleased that Toshiba has been selected to supply its QKD system, and SQBN Plus is a quantum-inspired program systems in this testbed, and to support this national project to help users development effective use cases. Q-STAR's new Quantum City Promotion and Quantum Materials Device and Sensing Subcommittee are also starting to discuss their visions. Show here the quantum city concept. This will enrich future society with quantum technology that can optimize individual fields like energy and transportation, and also promote overall optimization the city level. By showing optical solution in the, I show optimal solutions in cyberspace and discussing them with residents and governments. We aim to realize better future city planning with overall optimization that satisfies all parties. For this, we propose an industrial government activities, academia promotion systems, and its use the government and early adopter. So here are some examples of initiatives of quantum materials, devices, and sensors that are attracting attention in the business world. Need for public testing and verification facilities in crucial. So I have not forget to mention one of the major accomplishments of QSTAR, QRAMI, the quantum reference architecture model for industrialization. QRAMI was inspired by RAMI 4.0 as a model of viewing quantum business. It envisions the entire quantum-related domain on the three axes of domain, architecture and technology, and used to develop quantum use cases. We aim to make it a global tool, a platform for common understanding, not only within QSTAR, but also with other industry consortium around the globe. As I mentioned in our core policy goals and QSTAR policy goals to advance progress and applications of quantum technology through international cooperation. We have been communicating as a workshop with a consortium around the world, working closely especially with QEDC in the US, QEIC in Europe, and QIC in Canada. In end of January this year, we joined them in signing a memorandum of understanding to formally establish the International Council of Quantum Industry Associations. The consortium aims to strengthen communication and collaboration among the participating consortiums on goals and approaches to development of quantum technologies. Our main scope takes sharing information and events in each region, providing RD&I opportunities across countries and regions, especially for SMEs, and collaboration in areas where the synergies can be expected. The Council will also support an open, collaborative global quantum industry ecosystem, embracing entities with shared values. We believe that support for the ecosystem will benefit us all by realizing opportunity to commercialize research and innovation results. Also, the Council's joint advocacy can enlarge the impact and the extended outreach applications within the quantum industry. We also to facilitate exchanges and foster alignment in the critical areas common to the goal quantum industry, such as education and professional training, standardization, intellectual property and trade, and access to sufficient private and public capital. Our collaboration can draw new connection between companies worldwide, encouraging the establishment of business relationship and sustained global quantum market. In global activities, we are especially keen to build a map that allows us to grasp the states of quantum industry's global supply chain. This will help us to understand the strengths and the weakness of quantum industry, keep up with changing trends, create guidelines for industry development, and understanding supply chains that can be established under export control measures. I'm sure we will recognize that the coming age of quantum computing offers all of us many opportunities for a new age of industrial competitiveness and security. And I hope we can work together at the global level to achieve its promise. Thank you.
Thank you, Mr. Okada. Do you have any questions?
So thanks for overview of the Q-Star. I'm very familiar with your activities, but so it's like it feels like it's a think tank generating a lot of ideas and the plans. What do you do to realize your ideas and plans? I believe you probably need to work with government, or what's the process?
Yeah, this is my opinion. I think it's a short-term success. It is a very good point for the success to build industry. So, so we promote the annealing machine, icing machine. It is a realized technique, I think.
Do you do anything else to? I mean, again, you have like other plans like building a network, and then trying to do more R&D, and then you have policies. Yes. But do you have any other things that you do with the government or?
Yeah, as we are discussing about short time and the long time. Okay. Yeah, so but only long time. Industrial market is so will be tired. So the short-time success is very important for our view of the strategy of the Q-Star.
So you're not advocating for the short-term success right now. Okay.
Thank you for your presentation. And my question is, I understand the Q-Star is a government-led consortium, and Toshiba is the driving force of this consortium. You didn't mention about how you're going to involve local startups into this consortium to promote Japanese-born ideas and innovations to the world. Can you maybe touch upon how you're going to involve startups from Japan?
Yes, of course, we are involved. So about 10 members startup are there. So we'll promote more and more to go to the global. So in Japanese venture startups. Is that all right?
It's not a question to you, don't be afraid, but maybe a concrete example of the collaboration. Forgot exactly when it was, but there was, those Wassenaar arrangement about trade control, etc. So we heard that there was some government who wanted to put a limit. I think it was, I forgot what it was 200 qubits or whatsoever, and then over this is quantum control. So we collectively, QEDC, Q-Star, and QUIC, think of, okay, it's more delicate than this, it's more complex, and we collectively wrote a letter to those, whoever is taking the decision, and say, okay, be careful, we quantum industry, worldwide, this is how we see it, and please don't put control on this level, this kind of thing. So this is an example where it goes really beyond, and was in interest of all. There was no country-specific stuff. It was really as industry. So that's one little concrete example. So it's not that we systematically do that, but that's. But of course, I mean, what you mentioned, those, I mean, standardization, education, IP, those are obvious topics as well.